Good morning. I am Dr. J. Varnati, Head of the Department of B.Sc.It, belongs to School of Information Technology and also the Deputy Dean Academics. Well, today's session in data science using R, we are going to discuss about R objects. Now, before getting into R objects, let us have a basics of what is data structures. Now, a data structure is a particular way of organizing data in a computer so that it can be used effectively. The idea is to reduce the space and time complexities of different tasks. R's base data structure are organized by their dimensionality. What are the basic dimensionality? One dimension, two dimension and n dimension. And basically this also is categorized to either it will be of a homogeneous type or heterogeneous type. Now what is basically homogeneous type? In an homogeneous type, all elements must be of the identical type. In an heterogeneous type, the elements can often be of various types. Okay. Now let us see that in a dimension of one dimensionality, the inhomogeneous vector will belong to a homogeneous type, and in heterogeneous in one dimension list will come under that category. In two dimensional type, in homogeneous, matrix will fall in that homogeneous type and data frame will come into heterogeneous type. And in multidimensionality, we have array of homogeneous type. Well, now we are going to get into R objects. Now what is R objects? In R, the variables are not declared as some data type. The variables are assigned with R objects, and the data of the R object becomes the data of the variable. There are many types of R objects. Now we are going to see the frequently used R objects. The frequently used R objects are vectors, list, matrices, arrays, factors and data frames. Now let us get into the first R object, the vector. Now what is basically a vector? A vector is a sequence of data elements of the same basic type. Members in a vector are officially called as components. Now, when you want to create a vector with more than one element, you should use the function called C of function, which means you are going to combine the elements into a vector. Now, let us see that how we are going to create a vector. Now, for example, when I am going to create a vector, my name of the vector is called apple. Now, the function is C and I am going to give three components. The three components are red, green and yellow. That are the basic colors of the particular apple. Now, when I am going to print that particular vector, I have to give the command called print of the name of the vector. Now, what is the name of my vector? The name of my vector is print apple. Okay. Now, next one is that. Now, I want to know what is the class of the vector. Okay. So, for getting the class of the vector, I just give print. Within parentheses I give class of the vector name. So here you can see that I have just given here print class of apple. The next command that I have given here is that I want to know the length of the vector. The meaning is that how many components are there I have given inside my vector. That is whether I have given two components or three components. To find the length, I have just given the command, the function, the built-in function called length, which comprises of red, green and yellow. Now, to know my output, for each and everything I have to give print. Now, when you can see the output here, first print of apple. In print of apple, I am just giving red, green and yellow, that is my output. Now, next what is what? I want to know the class. What is the class? All of them are characters. So, it is giving there the output as character. Now, for the length, how many components are inside? There are three components inside. So, it is giving me the output as 3. Next thing. You can also combine the vectors. What do you mean by combining the vectors? I have two vectors. Now I want to combine both the vectors and I want to make it as a single vector. So now here you can see here, by again using the function C of, I am just combining both the vectors. I have a vector named N and I have a vector called S. Now I have created two vectors. My first vector is of integer type and my second vector is of character type. Now when you can see here, by using the function C of, I am just giving C of N comma S. So now both the vectors are combined, and when you see the output here, look into my output, it is 2, 3, 5, A, B, B, C, C, D, D, E. So both my vectors are combined. This is the basic way of combining the vectors. Now, next is vector arithmetics. Now, what do you mean by? Only thing is that we need not have to only combine or do any manipulation. You can also do some arithmetics with vectors. That is, I can add a vector, I can subtract a vector, I can divide a vector, I can multiply a vector. All these are permissible in vectors. So, that is what I just shown in this particular slide. I have two vectors, one is A, the second one is B. Now, I just want to multiply my first vector with the integer 5. That is also possible. So, when you see the output, here you will see that with 5 I am multiplying with A vector. So, I get my output as 5, 15, 25 and 35. So, that is possible with vector mathematics. And also I can do addition. I can add two vectors. Now, you see that I have a vector A, I have a vector B. Now, I am adding both the vectors A plus B. I am getting the output for that. Similarly, I can do the other operations like I can multiply two vectors, I can divide two vectors and I can subtract vectors. This is also possible with vectors. Now, vector index. Now, what do you mean by vector index? Now, supposing in a vector I just want to extract one particular element from my vector. Is it possible? Yes, it is possible with this operator called square bracket. By using that operator and giving that particular element number, I can extract a particular vector. For example, I have a vector called S which have 5 elements. Now, I want to take only the third element. Now, you can see here I have just put it S square bracket 3, meaning is that the element CC alone will be taken as output and it will be printed for you. So, this is the way that you can extract any element from a particular vector. The next is out of range vector. What do you mean by out of range index? Supposing my vector has got only 5 elements, but I am going to trying to extract a 10th element from the vector which is not at all in the particular element. In that case, it is going to give me the output called NA. What do you mean by NA? NA is not available. So, when a particular element is not there and you are trying to access it, it gives you NA, that is called not available. Now, good. Now, we are going to go to the next object called list. Now, what is basically a list? A list in an OR object contains many different types of elements, like inside it we have vectors, you can have functions, or you can have even another list within list called nested list. OR list is the object which contains elements of different types. You can have strings, you can have numbers, you can have vectors. So, this is heterogeneous. Now, how could you create a list in our programming? To create a list in our programming, we use the function called list of function. Now, you can see my example. I have created a list called X. My function is called list. Now, list is within the list I have given A, B and C. My A has got the value 2.5, it is numeric, B has a value true which is logical, and C is a sequence 1:3. So, here the elements are all heterogeneous and it is not homogeneous. Okay. Now, when I want to know the structure of a particular list, that is I want to know each and every component belongs to which particular type, then the function that I have to give is that str. Str means that I am going to find out the structure of my list. So, when I give str of x, look at my output, it says that I have 3 components. My first component is a numeric, that is it is 2.5. My second component is a logical one because it contains true, and my third component is a sequence which has the integer value 1:3. So, in this when you can see here the A, B and C, that is all called as tags in list. Well, now next thing, I do not want the tags to be printed, I just want my output alone to be printed. In that case, I just can give print of x. When I just give print of x, the A, B, C which was earlier printed all will be removed and only the value that I have given here alone will be printed from my list. Good. Now next object that we are going to see is called the matrix. So, you all have studied matrix right from your school days. Now, the same thing that we are going to implement it in this language. Now, basically what is a matrix? Matrix is nothing, it is a 2-dimensional rectangular data set, we call it as a matrix. A matrix is created with the help of vector input to the matrix function. On our matrix, what are the operations that we can perform is that we can do addition, we can do subtraction, multiplication and division, various operations we can do on matrix. In our matrix, elements are arranged in fixed number of rows and columns. Now, how to create a matrix? For creating a matrix, we use a function called matrix. Within that, we give some arguments. Now, what are the arguments that we give inside? Data, n row, n column, by row, dimension name. These are the arguments that we give inside the matrix function. Now, what is data? The data is the first argument, that is the input which give as a data elements. N row, that is the second argument, that means that how many rows that we are going to create in that matrix. Now, next is the n column, that is the third argument, that specifies how many columns that we are going to create in the matrix. Now, by row when we take it as true, it is a logical value, so that all the input elements are arranged by row. The last argument is the dimension name, that is a parameter that is assigned to the rows and the columns. This is an example for a matrix. So, now you can see here my matrix name is matrix 1. By using the matrix function, I am just creating a matrix. The row is 2 and my column is 3. So, that is 2 by 3 rows, and by row is true, meaning is that all the values are being assigned to that. So, when I give here a sprint matrix 1, my output is in the matrix format. This is how basically we create a matrix. Now, what are the matrix operations? As I already told you that we have various matrix operations like addition, subtraction, multiplication and division. So, that I am showing it as a program. Now, you can see here I have two matrices, one is R, the other one is S. The first matrix has got 4 rows and 3 columns, and the second matrix has also got 4 rows and 3 columns. Now, when I want to add two matrices, it is very simple. The only operator that I am going to use is plus. So, I just give R plus S. So, both the matrices are added here. Now, when I want to do the subtraction, the arithmetic operator that I am going to give here is minus. So, it just subtracts both the matrices. When it is a multiplication, I want to multiply two matrices, I am just going to give the asterisk symbol for multiplication, and if it is for division, we give the slash symbol. So, this is a very simple way of doing the mathematical operations. Basically, as I have told you in the previous classes, R is a language that mostly supports mathematical and statistical things. So, it is very easy when you want to do any operations on mathematics and statistics. R is a very well suited language for that. Now, this is the output for this addition, subtraction, multiplication and division of both the matrices that I showed you in the previous slide. Next, transpose. This is also one of the matrix operations. So, we can do what is a transpose of a matrix is that we are trying to interchange the columns and rows in a matrix, which is possible by using that. So, the very easy way of doing is that you just have to put it as T of that particular matrix, that is all. T is a function which is used to transpose the matrix. So, I have a original matrix with 3 rows and 2 columns. When I just give T of that particular matrix, now it has become 2 rows and 3 columns. The next one is array. The next object is an array. Array is the one which provides a programmer with the facility to store and memory location in the form of one or more dimensions. So, this is multi-dimension which can be used only with the concept of arrays. Arrays are basically in a rectangular shape which stores the data, and R can be created in array in our language by using the array of function. The syntax is array is a function name where we have certain arguments as data and the dimension that you have to give, that is the row size, column size, matrices and the dimension name. So, this is how basically we create an array. So, I give the function array, the data that I am going to give is 1:24, then I am giving the dimension, it should be 3 rows and 4 columns with 2 matrices. The next one is the R factor. So, the R factor is used to store the categorical data. Now, what you basically is a categorical variable is that which has got 2 or more categories, and it has no intrinsic order, there is no order in the categories. For example, male and female, in gender, blood group, we have various ordinal variables. Intrinsic ordering is low, medium, high, slow, medium, fast. Interval variable is 1:25. So, basically where we use these factors is that in statistical modeling we are using this concept of factors. Well, now this is how we basically do factors. We create a factor, then we generate a factor level, we access the component of the factor, then we modify the factor, then we use the factor function of that. Basically when we are creating a factor, we use a function called factor of, by which we take the vector as an input. Now this is how our factors are created. It takes limited number of different values and they are all called categorical variables. They can be stored as integers and strings. The factor is stored here as an integer and they have labels associated with this unique integers. So now what are the attributes of the factor is that it takes x as the input, which can be transformed into a vector, and you can tell how many levels are there and what are the labels. Now this is how basically we create a factor. Now I am just going to create a factor with the directions. I have 4 directions, north, west and south, but I am leaving out east and I am creating the direction. So see here, since it is a vector, we are just using it C of function and we are creating and we are giving 4 values in that. Now that direction is a name, I am creating a vector. Now I am converting that into a factor by using the factor of functions. Now when I give print directions, it will print by using the factor concept. Now next example, when you take, we have gender and I am just creating it as male, female, female, male. So I have 4 values. When I give print levels of gender, what it will give is that the output, when you can see here, it will give only female and male, because the value that is been repetitively given. So it takes only female and male, only 2 values it takes as the levels. Now when you, the next print, when you see here, print n levels of gender, that is how many levels are there? There are only 2 levels, one is the male, the other one is the female. So this is how basically we create a factor. So these are the various R objects that we have seen in today's class. In next class we will see that how we are going to utilize all these things in our program. Thank you very much.